It is acceptable to run the feeder at 760 amps continuously under specific conditions. Firstly, the wire must have a current capability of 760 amps at 75 degrees Celsius. Secondly, both circuit breakers, the 800 amp and 1000 amp ones, should be rated to handle conductors with a maximum current capability of 760 amps at 75 degrees Celsius. Thirdly, the ambient temperature should not exceed 75 degrees Celsius. The 80% rating of the 1000 amp circuit breaker does not automatically limit the continuous current capacity of the conductors connected to 80% of their current rating. The current capacity of the conductors is determined by their physical properties and the ambient temperature. In this scenario, the conductors have a current capability of 760 amps at 75 degrees Celsius, which is less than 80% of the circuit breaker rating, which is 800 amps. If a 1000 amp circuit breaker is supplied with only 200 amp wire, the maximum continuous current that the wire can handle is 200 amps, regardless of the rating of the circuit breaker. This means that the circuit breaker would be oversized and not provide adequate protection for the wire. The circuit breaker should be rated no higher than 200 amps in this case. The oversizing of the feeder wire may have been unintentional or due to equipment availability at the time of installation. It is recommended to rectify the situation by using properly sized conductors or adjusting the circuit breaker ratings to match the wire current capabilities. Regular monitoring of the feeder is advisable to ensure that it is operating within its intended parameters and that there are no overheating or other issues. Now let's delve deeper into the principles at play here. The National Electrical Code, or NEC, provides guidelines for the safe installation and operation of electrical systems. One of the fundamental concepts is ampacity, which refers to the current carrying capacity of a conductor in amps. This ampacity is determined by several factors, including the conductor's material, size, insulation type, and the surrounding ambient temperature. The NEC publishes tables, such as Table 310.15b16, that list the ampacities of various conductors based on these factors. It is crucial to consult these tables to ensure that the conductors used in an electrical system are adequately sized for the intended load. Circuit breakers are designed to protect electrical circuits from overcurrents, which can result from short circuits, ground faults, or excessive loads. The circuit breaker's rating in amps indicates the maximum current it can carry continuously without tripping. However, it's important to understand that circuit breakers also have an interrupting rating, which is the maximum fault current they can safely interrupt. When selecting a circuit breaker, both the ampacity and the interrupting rating must be considered. The 80% rating often mentioned in the context of circuit breakers refers to the continuous load limitation. According to the NEC, circuit breakers and fuses are generally designed to carry only 80% of their rated current continuously. This is to prevent overheating and premature failure of the overcurrent protection device. For example, a 100 amp circuit breaker should not be subjected to a continuous load exceeding 80 amps. There are, however, 100% rated circuit breakers available. These are specifically designed and tested to carry 100% of their rated current continuously, provided that they are installed in equipment that is also rated for 100% continuous duty. When using 100% rated circuit breakers, it's essential to ensure that the entire electrical system, including the conductors, terminals, and enclosures, is also rated for 100% continuous duty. Now let's consider the practical implications of these principles in the scenario presented. The feeder in question is using wire that has a maximum current capability of 760 amps at 75 degrees Celsius. This means that the wire can safely carry 760 amps continuously without exceeding its temperature rating. However, the 1000 amp circuit breaker in the power panel is only rated for 80% continuous duty, which means that it should not be subjected to a continuous load exceeding 800 amps. In this case, the wire's ampacity of 760 amps is less than the circuit breaker's 80% continuous current rating of 800 amps. Therefore, the feeder can be operated continuously at 760 amps, provided that the other conditions mentioned earlier are met. The 80% rating of the 1000 amp circuit breaker does not automatically limit the continuous current capacity of the conductors to 80% of their ampacity. The wire's ampacity is determined by its physical properties and the ambient temperature, not by the circuit breaker's rating. However, it's important to note that the circuit breaker must still provide adequate protection for the wire. In this case, the 1000 amp circuit breaker is oversized for the 760 amp wire. This means that the circuit breaker may not trip quickly enough to protect the wire from an overcurrent. Ideally, the circuit breaker should be sized closer to the wire's ampacity. For example, an 800 amp circuit breaker would provide better protection for the 760 amp wire. In a scenario where a 1000 amp circuit breaker is supplied with only 200 amp wire, the maximum continuous current that the wire can handle is 200 amps, regardless of the rating of the circuit breaker. The circuit breaker is designed to protect the circuit from overcurrents, but it cannot increase the wire's ampacity. In this case, the 1000 amp circuit breaker is grossly oversized for the 200 amp wire. This means that the circuit breaker would not trip until the current exceeds 1000 amps, which is far beyond the wire's ampacity. This could result in the wire overheating and potentially causing a fire. The NEC requires that overcurrent protection devices be sized to protect the conductors they supply. In this case, the circuit breaker should be rated no higher than 200 amps to provide adequate protection for the 200 amp wire. Now, let's discuss some additional considerations for electrical feeders. Firstly, voltage drop is an important factor to consider, especially in lawn feeders. Voltage drop occurs when the voltage at the load end of the feeder is lower than the voltage at the source end. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. To minimize voltage drop, conductors should be sized appropriately for the length and load of the feeder. Secondly, grounding is essential for electrical safety. Grounding provides a low impedance path for fault current to flow back to the source, which helps to trip the overcurrent protection device and prevent electrical shock. The NEC requires that all electrical equipment be properly grounded. This includes grounding the metal enclosures of equipment, as well as providing a grounding conductor within the feeder. Thirdly, harmonics can be a significant problem in electrical systems, especially those that supply nonlinear loads such as electronic equipment and adjustable speed drives. Harmonics are currents and voltages that are multiples of the fundamental frequency of the power system. Harmonics can cause overheating of equipment, misoperation of protective devices, and interference with communication systems. To mitigate harmonics, various techniques can be used, such as using harmonic filters, reactors, and transformers. Fourthly, surge protection is important to protect electrical equipment from voltage surges caused by lightning, switching transients, and other events. Voltage surges can damage or destroy sensitive electronic equipment. Surge protection devices, or SPDs, are designed to divert surge current away from the equipment and safely to ground. The NEC recommends that SPD be installed at the service entrance and at critical equipment locations. Fifthly, labeling is essential for proper identification and maintenance of electrical equipment. The NEC requires that all electrical equipment be clearly labeled with its voltage, current, and other relevant information. This helps to ensure that the equipment is operated and maintained safely. Sixthly, regular inspections and maintenance are essential for ensuring the safe and reliable operation of electrical systems. The NEC recommends that electrical systems be inspected and maintained regularly by qualified personnel. This includes inspecting conductors, connections, overcurrent protection devices, and other components for signs of wear, damage, or overheating. Any problems that are found should be corrected promptly to prevent potential hazards. Now let's turn our attention back to the specific feeder in question. Based on the information provided, it appears that the feeder wire may have been incorrectly sized. The wire has a maximum current capability of 760 amps at 75 degrees Celsius, while the 1000 amp circuit breaker is rated for 80% continuous duty, which is 800 amps. This means that the circuit breaker is oversized for the wire, and it may not provide adequate protection from overcurrents. It is recommended to rectify the situation by either replacing the wire with a larger size that is adequately protected by the 1000 amp circuit breaker, or replacing the 1000 amp circuit breaker with a smaller size that is appropriate for the 760 amp wire. In the meantime, it is important to monitor the feeder regularly to ensure that it is operating within its intended parameters and that there are no signs of overheating or other issues. This can be done by visually inspecting the conductors and connections for signs of discoloration or melting, as well as by using a thermal imaging camera to detect hot spots. If any problems are found, they should be corrected promptly to prevent potential hazards. In conclusion, understanding the principles of ampacity, circuit breaker ratings, and continuous current limitations is essential for the safe and reliable operation of electrical systems. By following the guidelines of the NEC and consulting with qualified electrical professionals, you can ensure that your electrical systems are properly designed, installed, and maintained.